All right, so today we are going to be using properties of exponents. So this is something that you guys should have reviewed last night, and it was from Algebra 1. And so just really quickly, I'll go through the different properties. I'm not concerned about you memorizing the names of the properties. I just want you to know how to use them. So don't worry about keeping straight the product of powers and powers of products. It's okay. All right. So product of powers, that's when I have variables or numbers with powers that are being multiplied together. So if I have x squared y to the 5th times x cubed y to the 7th z, if I write it out the long way, x squared would be x times x, and then y times y times y times y times y. That's my x squared y to the 5th, right? And I'm multiplying that times x 3 times and 7 y's. Okay. So what I really have is I have x times x times x times x times x. So what power is that? X to the 5th. And then I have y times 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 y. So what power is my y? Y to the 12th. And then I just have that one lonely z out there. So the shortcut, the property, is that when I'm multiplying with exponents, I can just add the exponents. 2 plus 3 is equal to 5. And 5 plus 7 is equal to 12. So it's a lot faster to just add the exponents, right? But if you find yourself doing a problem and you're like, okay, do I add, do I multiply, what am I supposed to do with the exponents? You can always write it out and figure it out that way if you can't remember the rule, okay? All right, so quotient of powers. We have the product of powers, we add our exponents. What do you suppose we do when we're dividing? We subtract the exponents. So that's the rule that you use. But again, if you can't remember for sure what you're supposed to do with it, you can write it out. I've got x times y times y times y times z on the top. I've got 4 x's on the bottom, a y, and 2 z's. And then whatever's the same on the top and the bottom, you can cancel out. I've got those two, I've got a y I can cancel out, and a z I can cancel out. So what am I left with on top? Y squared. And on the bottom I have x squared z. So what I usually do when I'm doing these problems is I just look at the fraction. I say, okay, I've got x's on the top and the bottom. Are there more x's on the top or the bottom? On the bottom. How many more are on the bottom? 2. So that means I've got x squared on the bottom. Then I look at my y's. I've got a y cubed and a y. And of course that y on the bottom is to the first power. So are there more y's on the top or the bottom? On top. How many more? By 2. So I've got y squared on top. And then finally I look at my z's. Are there more on the top or on the bottom? How many more are on the bottom? Just 1. So see, you end up with the same answer. Okay? All right. When you have a power of a power, again, what that means is I'm taking y to the 4th times itself 3 times. And y to the 4th is y times y times y times y times y times y times y. And so what power is my y at? 12, right? So when we have the product, the power of a power rather, I do 4 times 3 and I get 12. So that's when you multiply them. Yes? So you can do it directly. You don't. I'm writing it all out so you guys understand where the rule came from. And I'm also writing it out because sometimes people get mixed up and they don't remember when they're supposed to add and when they're supposed to multiply. So if you can't remember if you're supposed to add or if you're supposed to multiply, you can always write it out and then you'll be able to figure it out. And actually then that will reinforce the rule in your mind, like, oh yeah, this is the one where I multiply. that's an individual choice. Some of you might need to write them out. Some of you will be comfortable with the rules. It's just whatever works for you. Okay? It's not that I'm not expecting you to write them out. You don't have to write them out. I'm just showing you so you know where the rule comes from. Okay. All right. So next up we've got the power of a product. And so that means everything inside of there. If I wrote it out the long way, I would have 3xy times 3xy times 3xy times 3xy. The main thing that I see happening is that people forget that 3 is to, that 3 is to a power as well. And so when you have the power of a product, everything has to be raised to the power of 4. Not just the x and the y are raised to the 4th power, but the 3 is also raised to the 4th power. And so you can see when you write it out, it becomes obvious that you're having to raise it to the 4th power. And so you get 81 x to the 4th, y to the 4th. And so a quotient, it's the same idea. Everything in the quotient needs to be raised to the power. Am I just going to square the x, or do I have to square the 2 also? What do you guys think? I have to square the 2 also, because that means 2x times 2x over 7y times 7y. So that one's pretty easy to write out. But if you don't write it out, you have 2 squared x squared over 7 squared y squared. That would be using the shortcut, just knowing that everything gets raised to the power. Either way, you get 4x squared over 49y squared. Yes, what's your question?
It was like, say like 20x squared or like 40x squared, would you reduce it?
If I had, yes, if the answer was reducible, yes. In fact, if it was 20x squared over 40y squared, it probably could have been reduced before you, well, 20 is not a perfect square, so it's not going to come out to that probably. But yeah, you can if you can reduce the fraction, you should reduce it. And sometimes you can reduce it before you do the multiplication, and so then it doesn't become a problem in the answer. All right, 0 exponent. So anything to the 0 power is equal to 1. Very good. So, and does it matter how big the number is? If it's, 6,235,875 to the 0 power, it's still going to be 1. Okay? And now that we've talked about those other properties, you can kind of see how it works out. If I have, say I had x to the 4th times x to the negative 4, I would have x to the 0, wouldn't I? And if I write it out moving the negative, I would have x to the 4th on top and x to the 4th on the bottom, and anything divided by itself is equal to 1. So do you see how x to the 0 equals 1? Hopefully. Yes.
So the 25x to 0.
Oh, I made a mistake. Yes. It's 25 times 1. Oh my gosh, all day. You are the first person to catch that I made that mistake. I was so focused on the 0 that I forgot about the 25 sitting there. Yes, the 25 is not being raised to the power, so it should be 25. Good catch. Okay, negative exponents means that you have to flip it over. Oh, that's all connected. Okay. Because if I have x to the negative 1, that's just 1 over x. So when there's a whole fraction, you essentially just take the reciprocal. So this would equal 7 over 2 to the 3rd power, which is 7 to the 3rd over 2 to the 3rd, which is 343 over 8. And if we look at this last example real quickly, I see that I have an x to the negative 1 here and a y to the negative 1 there. So whenever you have a negative exponent, it has to move. If it's on the top, it moves to the bottom. If it's on the bottom, it moves to the top. Okay, so one way of thinking of it is he's negative. He's not a very happy guy, but as soon as you move him, he becomes positive and he's happy again. Okay? So if I think of it that way, then that means I've got my y squared, he was already happy, and I put the y to the first on top. My x squared was happy, and then I moved the other guy, he's happy now. And so it equals y cubed over x cubed. Okay? And if that totally confuses you, ignore the happy and sad thing. Okay. All right, then the other thing we're going to talk about are polynomials. We're just going to barely touch on these. We're just doing the very start of this chapter. And again, this is pretty much mostly review from Algebra 1. In order to be a polynomial, all of the exponents have to be whole numbers. So your whole numbers are 0, 1, 2, 3, etc. Is a negative number a whole number? No, it's not. A negative number is an integer. So can I have negative exponents? No, I can't. Not and have it be a polynomial. And then the other thing that has to be present is the coefficients have to all be real numbers. So we're not going to have any imaginary numbers in our polynomials. And then the degree of a polynomial, just so you know, the degree of a polynomial is equal to whatever the highest exponent is in the polynomial. So this next chart, I'm not expecting you to copy this down. This is out of your book. It's on page 337 in the textbook. If I were you, I would just worry about this front part where they talk about the degree and the type. But if you want to go back and copy it down from the textbook, you're welcome to. Or rewatch the video and pause it. Okay, so when we're classifying polynomials, again, this is something we covered in Algebra 1. If the degree is 0, it's a constant. First degree is linear. Second degree quadratic. That's what we just did in Chapter 4, a whole bunch of quadratics. Third degree is cubic. Fourth degree is quartic. And so again, the degree is coming from that highest exponent, okay? When there's no exponent, what do we assume it is? A 1, right? So we assume we've got a 1 right there. And then actually, this is technically times x to the 0 power. And so this is the 0 degree. So when we graph a constant, do you guys remember what was special about that line? Y equals, say y equals negative 14. What kind of line is it going to be? It's going to be horizontal, exactly. And then our linear equations, that's your basic y equals mx plus b, right? So now our line has a little bit of a slope to it. Quadratics, we just graphed a whole bunch of those. What do they look like? It looks like a U, yeah. So a cubic one, what happens is we add one more turn to the graph. So it turns twice, basically. And then quartic, we add another turn to the graph, and it would look like that. So every time you raise the degree, you add one more turn to the graph. Does anybody remember what fifth degree was? Because we did talk about that in Algebra 1 also. It's related to cinco. It's from the Latin, I believe. Quintic, very good. Just like when you have quintuplets, right? 5 twins or whatever. Okay, so yeah, quintic. All right. So when we look at this expression, or this equation rather, I want to know whether or not it is a polynomial function. So is this one a polynomial function? What do you think? Yes or no? Well, all the exponents are whole numbers, and all of my coefficients are real numbers. So yes, it is polynomial, and it's already in standard form. Because what do I mean by standard form? What is the standard form of a polynomial? So in standard form, the exponents are written in descending order, right? Oops. So the highest one first, and the lowest one last. And the leading coefficient then is the one that's out in front, the one from the first term. So what's the leading coefficient for this particular polynomial? What do I assume is in front of that x to the fourth? A 1, right. So its degree is its fourth degree, which means it's quartic. And its leading coefficient is 1. Now, is this one written in standard form? No, it's not. So we need to rearrange it. So the pi x squared would be first, and then 7x, because that's x to the first, and then minus root 3. And so what's the degree on this one? Second degree, which makes it quadratic. And the leading coefficient is pi. Is pi a real number? Yes, it is. It's just irrational, but it's still real. Okay? All right. What about this one? Is that a polynomial? What do you think? No, we've got a -1 out there, so that's not a polynomial. And how about this one? Is that a polynomial? Why do you say no?
That's like 5 variables.
Well, there's only one variable, but look at where that one is. Okay, so it's not a polynomial because the variable is an exponent. Okay, so the last thing that you guys need to know, this is really easy, you already know how to do it. When they say to evaluate by direct substitution, all they're saying is plug it in. So you're going to have some problems tonight where you have to plug in a value for x and figure out what the value of the polynomial is. So you'd have 2 times 3 to the 4th minus 5 times 3 to the 3rd minus 4 times 3 plus 8. So that's 2 times 81 minus 5 times 27 minus 12 plus 8. And so all together it ends up equaling 23. So f of 3 would equal 23. All right, that's it for today.